Three, two, one.
Hello everyone, welcome to Tonight in STEM. I'm your host, Juan. Zepeda. This is a show where I interview professionals in the field of, well, science, technology, engineering, and mathematics. How's everyone doing today for another show? Like I mentioned, I interview professionals in STEM. Today we have Doctora Andrea Sanchez. So let's jump right to her and welcome her on our show today. How are you doing today?
Good evening, Juan. I'm doing great. How are you doing?
I'm good. Where are you located?
I'm located in Columbus, Ohio, Midwest.
The Midwest. Actually, I just came from the Midwest, and the weather for me is not okay. But how's the weather for you over there?
It's for November. It's wonderful. It's mid 40s right now. I think earlier was around mid 50s with sun. It's really good for November.
Well,
Trust
I
me.
bet you can't complain, but I was complaining a lot when I was in the Midwest. But thank you for being on today on Tonight in STEM.
No, thank you for the invitation. To
Awesome.
reflect.
So before we get started, a little bit about Andrea Sanchez. She actually currently works for DMVGL. She was born in Venezuela. She has a long history with SHIP, a lot of leadership roles. She actually got the SHIP Graduate Student Role Model in 2014. She actually also got a book award for the Corrosion Society, which I didn't know there was a Corrosion Society. We'll hear about that in a little bit. Um, but I think that's enough because I know you have a lot more to say, and me saying it will not serve it justice. So I'll let you say. And the first question we'll get started with, it's the classic question. How did you get started in STEM?
In STEM, well, I will have to say number one because of my dad. He is a chemical engineer.
Oh, wow.
And he's a professor in the Universidad de Zulia. This is in the state of Zulia in Venezuela. So I think that he always sort of embraced science and math in my childhood. Not only him talking about it and explaining how things work and understanding the whys, but also because we have this huge library and it's just filled with books on corrosion, which is his specialty, which happens to be mine too, and material science, chemistry, algebra, math. So I think that he had a lot of influence on me. But also my mom, despite her not having an engineering degree or not any science related um, uh, degree. She's a teacher, retired already for social science, but she is a very good problem solver. Um, she is Mrs. Fix It. Doesn't work. She comes up with an idea and she's a problem solver. She's really good at it. And also just to see how I would go to a hardware store with my mom, and my mom fixing stuff, grabbing a hammer, or
Wow.
screwdriver. It just was amazing to see that. And
So you had two very strong role models.
yes, very, very two strong role models, and also understanding how things work. And if they don't work, let's try to fix it rather than replacing it.
That's
And
the engineer mentality, right?
that's linear mentality. And if it doesn't work, then why it doesn't work, and who can
Exactly.
help us solve it. And yeah, and later, so those are my first influencers. And then when I was in middle school, end of middle school, I took chemistry and physics, and it really, I really really liked it, especially physics. It was very easy for me, or it just makes sense. It clicked. I would like to say it
Very
like that.
logical.
Yeah. So I really liked it. And then by the time I was finishing high school, I was actually debating, should I study mechanical engineering, chemical engineering, even industrial engineering was an
Right.
option. Uh, so I was, and my school really promoted to take aptitude tests.
Okay.
So I took several of those, and
So
also
what
when I
is
was
a aptitude test for the people that don't know?
Oh, okay, yeah. So an aptitude test is pretty much a test that asks you 150 questions or so,
Okay.
and answering those questions based on those answers that you give, they can tell you what are your strongest skills or what are you most passionate about. So it's either science, humanities, arts, history, philosophy. So when I took those, definitely science. I was in the science part, and it was able, and then it recommended some career paths to me, some degrees that I should consider. Among those was just chemistry, uh, chemical engineering, mechanical engineering, physics, industrial engineering. So definitely I was going on the path of
Early
science.
on, you're lenient toward those kind of majors.
Yeah, and also, I give credit to my really good professors in my middle school and in high school. I think that because I think the reason why physics clicked and chemistry clicked is because the way they taught it. Because I understand that if you don't have it, if you don't have a very good professor, you can either love it or hate it.
Correct, and it's a very dangerous
Mhm.
situation. I've had situations where you have websites here in the United States. I don't know, like Rate My Professor, that you live and die by them because you want the best professor to teach that class. If not,
Right.
like you said, it could be the worst thing.
Exactly. So just not no having my parents being this role models, but also professors, and I think also that I noticed that they were doing it because they like it, not just because I'm doing this because you know just because I have a job and I just want to get it out, get it home soon. No, they were passionate. You ask questions and they will respond kindly. I mean, obviously many of them were really tough, but that's the challenge, and yeah, so I enjoy it.
So, at what point did you come from Venezuela to the States, and why?
So I pursued my chemical engineering degree in Venezuela, and then before graduating, I had a period of time basically free where I could do my internships. And in Venezuela, it's mandatory that you do a thesis for as an undergraduate. Everybody has to
Okay,
do an internship and a thesis.
okay.
So you have to do some research prior to graduating. So while doing my undergraduate research, I had the professor that helped me. She encouraged me to go to grad school, and then I signed up for some classes. Also, I spoke to my dad, and he also said it's a great idea. So I took some classes already in grad school, but being as an undergrad. And by the end of that semester, this professor, she told me that there was a possibility of an opening for a PhD student in the University of South Florida,
Oh
and
wow.
if I would like to go. At this moment in my life, PhD sounded like, whoa, that's like when you're, I don't know, 50 and you do that. I just had no
It just
idea.
takes a long time, so it's
Yeah,
daunting,
I
right?
was already considering the idea of doing a master's, especially because another person that has been of a lot of influence in my life has my older sister, Erica. She also has a chemical engineering degree, and
Oh.
then she came to the States to pursue master's. So I was little. We were 9 years apart. So when she left and I was still in middle school, even just to see her doing that, I'm like, oh, I want to do that one day. And that sounds great, to study abroad and get better education
Correct.
elsewhere. So that really pushed me. And then when I received this notification from my undergraduate advisor, I already have heard of the University of South Florida. So I called this professor. His name is Alberto Sagüez, and I told him that I would like to know more of the PhD position that he had open, because I knew that um, he was about to win a grant from the Florida Department of Transportation.
Oh, okay.
So he told me, yeah, let's set up an interview, and he happens to be Argentinian. So I'm like, well, I mean, most likely the call will be in Spanish, right? Makes sense. That's what I thought. Naive me at that time. And I talked to him and I'm like, oh, hi, I heard that you have a position. Could you, I mean, I've seen some of your papers. I would like to know more about it. And I said this in Spanish and he immediately switched to English. He's like, okay, yeah, please. So he just started saying, send me your resume. And then I sent him all. So basically, it was a short introduction where I sent him all my transcripts, my resume, and then we had another call, and that's when he talked of. He knew that in my resume that I had some background in corrosion engineering because that was part of my undergraduate research.
Correct.
But I applied in oil and gas in the oil and gas industry as an undergrad. He wanted to. His field was corrosion engineering, but in infrastructure.
Oh, okay.
So at that point, I said, well, I mean, it should be the same, right? Action.
In theory, it should be the same.
I said the oxygen reduces corrosion. Again, naive. I was very naive and didn't know much about it. But he explained. We had like an hour conversation, and he was very explicit on the project that he had in mind and the kind of candidate he was looking for. So I have after that a couple of other interviews with his PhD students.
Okay.
And in here they told me like the way he operates, how he works, and then he sent me some papers to read that were related to the project that he had in mind, and it was really fascinating. It was modeling the durability of bridges, of reinforced concrete bridges in marine environments, which is mainly the whole area of Florida.
Yes.
So that was so it was. I didn't know much about mathematical modeling at that moment. I was just doing much of lab work as an undergrad researcher. But it really fascinated me the fact that he said you will have both. You will have laboratory experience and then you will also have modeling experience. And I'm like, I like this. I think I was obviously not, I wouldn't call it scared, but just wondering like, can I do this? And then that's when I look into the program and look into the classes that I needed to take. And this is where it helped a lot to talk to other PhD students because they guide me. Depending on your project, this is the classes you will have to take. And I didn't know much about grad school here in the U.S., but the good thing is that the program of materials in the University of South Florida give me the opportunity to take classes from different departments.
So this was when you were at the university already?
No. This is before. This is what the PhD students were telling me because I thought that this is the thing. So I graduated. My bachelor's was a chemical engineer, but then he told me you will be receiving a PhD in civil engineering. Oh. I'm like, well, I don't know anything about civil engineering. But he said, well, if you look into the program, in civil engineering, there is the materials program. And the materials program is mainly on concrete and cementitious materials. So here's where you take classes that are related to corrosion and to durability and mathematical modeling for reinforced concrete structures. But then I could take other classes in mechanical engineering that are related, for instance, to advanced materials, or in chemical engineering department that are characterization of materials. And then from electrical engineering, actually, I took a vector analysis class. So it was fascinating to see that I could combine knowledge from various fields. Correct. Because I would say when people say, "Oh, so you're a civil engineer," I'm like, "No, I'm a corrosion engineer." So I like define myself because. So I
have a question about that. So you had a very general background.
Yeah.
A chemical engineer, but you were going to get your PhD in civil engineering.
Mm-hmm.
First, you were scared, but these PhD students were telling you that to not be scared because you were going to take a lot of classes. What other thing did your professor, what was he looking for?
Mhm.
For what specific things was he looking for to be to get his next student? In this case, you. What was he looking for you specifically?
He really wanted a person with understanding of the corrosion engineering fundamentals. So it actually was very helpful that I took those two classes of grad school as being an undergrad,
Correct.
because those classes were corrosion, corrosion, basic corrosion for grad school, so advanced corrosion. Just doing that translation. And I also took material science and engineering class. So they were both somewhat related to, well, also the master's was in corrosion engineering. So I started with that. So he was really looking someone that was passionate in corrosion,
Correct.
and also that had some experience with laboratory, especially with electrochemical techniques, which I did as an undergrad in my research.
Correct. So
And
I know.
also good grades. And yeah.
Correct. So you're starting to mention corrosion a lot,
Yeah.
and when I think of corrosion, I think rust, this material, the structure getting weaker.
Mhm.
Can you define it, what corrosion is, where it's found, how it's formed, maybe at a high level?
Yeah. So corrosion is just the electrochemical reaction of metals or alloys. By alloys, I mean, for instance, it could be stainless steel that has iron, carbon, and other compounds has chrome, manganese, etc. So it's an electrochemical reaction of these metals and alloys with its environment. So what happens is that these materials, you cannot find a metal just buried in the ground. They're basically, you find it as a metal ore, and then you need to apply. And I'm just saying this very in a simplistic way, but applied a lot of energy to turn that iron into an actual steel. In order to convert that iron to that steel, you have to extract it. It comes from ore. You combine it with carbon, and we're talking a very high temperatures of these processes happening, where they have to be melted, and then you have your steel sheet or your metal. But what happens is that these metals have a form of anodes and cathodes. They're just compounds all together, and then they react with its environment. By its environment, what I mean is that the iron that is in the steel is going to thermodynamically is going to its original state, meaning that it's going back to where it was, to its ore.
Huh.
So that's the oxidation that we see, and that's why it gets that orangey color, because that's how it's found in nature. But in order that to happen, you need four things for corrosion to happen. You need an anodic reaction, and that anodic reaction is the oxidation of the iron. So it's the iron oxide converting into ferrous ions or ferric ions. So that means Fe++ or Fe+++. And then also you need a cathodic reaction, which generally could be the reduction of oxygen, right? That's the reduction of oxygen. You need electrical. You need oh my god, I forgot the name. You need an electrical conductor. Okay. That's where the electrons are going to travel from the iron that is oxidizing, because then you have iron oxide that converts to Fe++, but then you have electrons. Those electrons travel to the electroconductor to the for the oxygen reduction to occur. But then you also need an ionic conductor where the ions are going to travel as well. Oh. If you don't have those four elements, then corrosion won't happen. You need these four things to happen. So anodic reaction, a cathodic reaction, an electrical conductor, and an ionic conductor. Now, let me put this in easier way. Let's just let's assume that you have a nail, just a steel nail, and you have it so you have it partially submerged in water.
Okay.
So in the nail, you will have your anodic reaction happening because the nail is made from steel, so you have your iron there. This nail is it's in a humid environment because we said that it's partially submerged.
Okay.
So then from there, it's in a humid environment, so there's oxygen available.
Okay.
So then you have your oxygen, and you have your you have your iron there, your oxygen, and then your electrical conductor will be the same metal. That's where the electrons are going to flow within that nail. And then the ionic conductor is what we call the electrolyte, which is where the ions flow. This will be in the water. Generally, this rate of ions traveling are increased when you actually have salts to this water.
Oh, okay, that makes sense. So that's why. No, that's why in salty environments, corrosion happens faster.
Why? Yeah, I mean mainly because that's electrolyte. Yeah, if this metal is exposed to an electrolyte, then that's where the ions are going to travel. So if you get rid of one of the four, really corrosion will not occur. But usually the four, when, for instance, that you're saying, that's why in chloride environment. So if you have a steel embedded in concrete, so what happens in steel and concrete is that you have a layer of concrete protecting the steel, and then you have the ions, and these ions actually travel to the concrete pores, not through the concrete pores, because concrete is not, it's a porous material. So this is where the aggressive species as chlorides, they travel, right? And then they get into the surface of the steel. When they get to the surface of the steel, they break down a film that actually was protecting the steel from corrosion. This film is called the passive layer. When the chloride ions break down this film, then your anodic and your cathodic reaction occurs, and then there is a buildup of corrosion products. And concrete has very low compressive strength, so then the corrosion starts to accumulate at the surface of the steel, and then that's when there is sufficient amount of corrosion products at the surface of the steel, then that's when corrosion cracks. And that's when you see cracks or chunks of concrete falling. That's when you see these kind of things. Not necessarily corrosion occurs just because of chlorides. This can also happen in environments where there is high concentrations of carbon dioxide. So if you have a reinforced concrete structure located near a factory that is emitting a lot of CO2, this can happen. This can happen a lot, or even just in urban areas where CO2 concentrations can be significantly higher than other rural areas.
So, to get your PhD, your specialty was specifically in what you're telling us, in the concrete and steel.
Yeah.
How much of modeling were you doing? Can you go into depth a little bit more into that?
Yeah. So basically, what I did, the project involved modeling the durability of reinforced concrete structures. This sounds very generic, but we were focusing on remember how I told you that when the chlorides ingress through the concrete pores, they break down the passive layer. Mm-hmm. Usually in mathematical models, they assume that there is a fixed amount of chlorides needed to break down that passive layer. Okay. And usually that number is very conservative. This number is known as the chloride corrosion threshold. Okay. So they assume that it's a fixed value and that it's independent of other mechanisms happening in this environment. But before starting my research, I did an intensive literature search. It was very well known that the chloride threshold value was not fixed. It was not as conservative as it was being used in mathematical equations to predict how long concrete will last. And then finding out that it was not fixed. Then okay, what is this variable depend on? So it depends on many things. It depends on the material, the steel of the structure, the quality of the concrete, and also something that is called depends on the potential, on the electrical potential of the embedded steel bar. Because when you have a steel bar embedded in concrete,
Correct.
it has there's a difference in potential that you can encounter there, right? So for instance, this electrical potential, this voltage difference, to put it in like that in those words, will vary depending on the oxygen availability, and that depends a lot on the quality of concrete. So if you have a structure that is submerged, for instance, in the sea, and then you measure this potential, your potential will have a very negative value. But if you have it exposed to the atmosphere, then this will have values still negative, but towards more positive values. So I would say that if we're comparing this to typical calorimeter electrode, this is just a reference to see how far you are, just a reference electrode to know what is your potential. You will find values in the submerged area of minus 600, and then on the atmospheric area of minus 150. So we're talking about there's around minus 600 millivolts of difference between the two. So with previous work, we noticed that what they did experimental lab work where they had little specimens of concrete with embedded steel bar. This was a work done by a Spanish group in Madrid, and so they did little testings, and they polarized. And by polarize, I mean is that they electrically shift the potential of these concrete samples with embedded steel bar to see how this chloride corrosion threshold value changes by applying an electric field. So the problem was that there was a lot of skepticism, because people argue that these samples were very small, and that more research was needed. I mean, for me, the experiment was great. They were small samples, but they did it with a lot of different concrete mixed proportions. So what I proposed in my research was to redo their experiments, but with a different geometry, with a different type of metal, with a different type of mixed proportions, redo it in a small scale. Then, depending on the results that I receive, if I confirm and I validate that the chloride corrosion threshold changes with the potential of the steel, then I will proceed to build larger samples of concrete. Wow. And that's what I did. And then going back to your question, sorry, well, that took long. Based on those results that I would obtain experimentally, I will use those results in my mathematical model, where I would say that the chloride threshold depends on the electric potential of the steel, and that it's not a fixed value. So I use those results, and then I actually compare what would be the result of forecasting the durability of a structure by using a fixed chloride corrosion threshold and by using the chloride threshold dependence on potential. And what we saw is that mainly you're using very over-conservative values, and that concrete mix proportions can be made and done in a more efficient and optimal way, than it has been done in the last 30 years. Yeah.
So what would be So by the way, this is fascinating. So
Okay.
keep going, because yeah, this, like wow, like when you think, okay, for example, my background is very software engineer, very focused in that.
Uh,
But when you think corrosion, I don't think in all these little tiny things. But this,
yeah.
again, we're pushing the point that a PhD student will go into depth and find everything, and they're fascinated by this.
Yeah.
And it seems okay. So here's one question: why corrosion? What if corrosion fascinates you?
What fascinates me of corrosion is just how materials, you know, uh, just by nature, they really want to go to their initial state spontaneously. There's this spontaneous reaction where they want to go uh, to their
Native, original.
to the original state. That's what I mean. To the original state where they as they are originally found in
Right.
nature. So that's very fascinating from a material standpoint. And then also how these materials interact with this reaction. Because in here, I'm just telling you of what is corrosion in reinforced concrete. But corrosion in many industries, it varies a lot. It will depend on temperature, it will depend, for instance, in pipelines, a whole different animal. What's carrying in oil and gas pipelines?
Yeah.
What is the product being carried there? Is it a carbon dioxide? Is it H2S? The sand. Well, sand doesn't cause corrosion, but it can affect other variables.
Correct.
The pressure, the temperature. So it fascinates me that we are a society that are very material dependent. I mean, wherever you look, we're so dependent on materials, and I think that steel has played a significant role in a society in our modern times. Especially stainless steel. I think that without stainless steel, we would not be what we are today because with the stainless steel, it's in the food industry.
Correct.
Mainly, right? And stainless steel is in refineries where we refine our fuel, our fossil fuels coming from the ground. It's in our kitchens. It's everywhere. It's in our cars. And then also, we are a very material-driven society, and mainly in steel and alloys. It's a car, making our cars more efficient, and how can we have even a safer society and efficient, right? So that really fascinated me. So we just see how corrosion really can accelerate the degradation if it's not prevented, if it's not well maintained, or if corrosion is not considered during the design phase of many structures.
That's very fascinating, the way to look at that, and how dependent we are. And it's very fascinating to look at that, and how dependent we are on that. And how it can affect many industries, not just maybe structures in the civil industry, but
it's airplanes, the auto industry, the aerospace industry. Yeah. It's petrochemical industry, so petroleum, everything.
So you got your PhD, and then you went into industry. Now you work for DMV Geo. Can you talk about who they are and what you do there?
So DMVGL is a company that mainly does certification and technical advisory for the oil and gas, energy, and maritime industry. It all started 150 years ago in the maritime industry, mainly by the development of certifications. But it has, acquired other companies. And I am in the Strategic Research and Innovation Group in the Materials Program. So we are mainly developing risk assessment models, mainly for the oil and gas industry, where we are predicting when there will be material failure due to corrosion in oil and gas pipelines, either internally or externally. So we are using this mathematical approach called Bayesian networks, and this, I don't know if you're familiar with Bayes' theorem. Basically, it's on conditional probability. So if you want, the probability of A given B, what would be the probability? So you have a prior probability, and then based on that prior probability, you can estimate the posterior probability.
Okay.
So there's a lot of probability involved. But in the 1980s, there was this professor from UCLA, Judea Pearl. He is in the artificial intelligence industry. Well, that's not an industry. It's just a subject.
That subject matter, AI.
Yes, yeah. He came up with this Bayesian network. So it's basically our graphical models where you can identify the cause and the consequence of various mechanisms, and you can combine various mechanisms based on that knowledge of the cause and the consequence of things, and you can combine that all in one framework. Sounds easy, but then, for instance, if you have a variable A depending on B, A will have different states. So say that temperature will affect. Well, here's a quick example. Let's see. Trying to think. Well, temperature will affect how good your egg will be cooked. Let's say like that. Let's put it on foot. So then it's a probabilistic approach. So then you will have different states of temperature. So you will start with 10 degrees, 20 degrees, 15 degrees. I'm talking Celsius, by the way, because I guess Fahrenheit that would be too cold. And then depending on so you have different states of temperature, and then basically your output for if you cook your egg at that temperature will be good or bad. But sometimes I think that nature is very stochastic, so there is just not one single number for events. So for instance, when you ask me how is the temperature, I didn't say the temperature is 45.7 Fahrenheit. I
said it was nice.
It was nice. So for me, I would say, well, the temperature is probably between 40 and 45 Fahrenheit, something like that. I don't know the exact value, but I can tell you based on my experience. This is like my prior, that is between 40 and 45. So then that's where you use a distribution. Say, okay, the temperature is between 40 and 45. And then you compare that to the actual real temperature, and probably if I go to the Weather Channel, it would say 43. So okay, I wasn't that off. So I was somewhat in that range. So it's the same thing with Bayesian networks. You have some prior probability on going back to the egg and temperature. You have a range when you know that your temperature will be cooked well, and then you can use that distribution to know will my egg will be good or bad. The answer will not be good 100%, no 0%. It will be good 75%.
Probabilities, yes.
Then no 25%. But it will give you enough information to make a decision. So it's a decision-making tool based on Bayes' theorem, which is a probabilistic approach. But then you are able to connect various mechanisms that all occur at the same time to find how they can all interact so an event could happen.
Right.
And the other cool thing is that it's reversible. So if you know that an event will happen, you can actually backtrack and find out what was the most probable cause. So there is no 100% certainty in here.
Correct.
It's very probabilistic, but it's good when there is it's a very useful approach when there is a lot of uncertainty or if certain mechanisms are not fully understood. Or it could be like how we use it mainly, that sometimes there's just not enough data. So if you want to do a forecast, if you want to predict from 10 years from now, you cannot predict usually what happened yesterday. The fact that yesterday it rained doesn't mean that tomorrow is going to rain too.
Correct.
So then you will have to do some guessing, some educated guesses. And then here's that where you use certain distributions and probability to actually predict what will be the most likely set of conditions under different variables to predict an event.
So That's all fascinating. So here's another fascinating question. Um, why did you choose to go in industry after you got your PhD? Most people that I've talked to, they usually become professors or go the academic route. Why
Mhm.
industry? Why did you choose that? And what advice would you give international students who kind of want to do the same?
Yeah, actually, based on some numbers that I read, 2/3 of grad students actually go to industry
Okay.
than the academic track. For me, mainly was that I didn't feel ready to become a to take to be on the on the to be a professor. It's basically the same. I didn't feel ready to become a professor. I
By the
feel.
way,
Huh?
I disagree because your explanations are fascinating and are out of this world. But okay, sorry.
I really appreciate that, but I didn't feel at the time that I was ready. I kind of wanted to explore a bit more. So mainly this is where people actually go and do a postdoc, and then they usually are in another field, and then they apply their skills to that.
So,
But
what is a
I wanted.
postdoc? So, actually, a lot of people don't know what a postdoc is.
Oh,
Can you
okay,
explain what
yeah.
a postdoc is?
So postdoc is when you graduate from your PhD, and then you still want to continue on that research and academic track. Then you usually go to another university with a whole different, usually in another field, and then you do some 1 or 2 years of research at that lab. But as a postdoc, you don't need to take classes, so it's all research. And usually, well, I would say generally, mainly of the time, you're funded. So it's very similar to doing a PhD. It's just that now you have reached a point where you actually are the principal investigator of a certain topic in a certain research topic, and then you're funded, and you're also being mentored by the professor, by the tenure professor or professors.
Correct.
To be one.
So, does this serve as like a transition point into maybe
It's
become a professor?
it's usually a transition point because with this experience there you're able to publish, to have more publications,
Okay.
to have a different to have a more experience in the research field, because you're actually going with another professor, so everybody has its own ways to do research, and each university also has a different culture.
Correct.
So it's a way to explore more into depth a certain field, but also learn of other ways of doing research, and also learning how other laboratories do their work.
Okay.
Hmm.
So now I know in the beginning I teased about ship and your heavy involvement in there, and I think you've had 4, 5, 6, 7, 8 positions there. There, but I want to dive into that. And why did you choose ship, and then why did you choose to get so many positions each year? I guess grabbing more responsibility and taking on more.
Yeah. So I think that as a grad student, it's important that you also have life outside the laboratory.
That's always a
Yeah.
goal in STEM.
You can just not be, just be in your lab all day, all night. You need to acquire other skills for your career. I mean, hey, I respect everyone. In the sense that if you don't agree with this, that's fine. For me, I felt it because I like to. I can't do the same task over and over again for 20. I need to have a mental break. Either if it's still if still it's a whole different, even if it's still studying, but it's a whole different subject. That's not the way I operate. But also, I wanted to acquire skills that I knew that being in the lab, I would not enhance them or excel at them. And so one of these was to make new friends outside the lab. And the way I got into chef was, I can tell you a really quick story. This is the importance of marketing. I remember a friend, he would always use a chef t-shirt, and his name is David Klinovsky. He would always use a chef t-shirt. I'm like, what is that? Oh, the Society of Hispanic Professional Engineers. You should come. At this point, when I arrived from Venezuela to grad school, I had no idea what the chef was. So I went once to their meetings.
Did
and
they have free pizza?
I have free pizza. Just for the free pizza, no. And I liked it. I really liked the atmosphere and seeing all these students very engaged on the organization, and they were, in how I saw that it was largely attended. It was the first event of the semester, and it was a surprise to see, young kids just already talking as professionals and the way they would express, and and preparing themselves, and I need to have that my resume, my elevator pitch, this, and they already know this is what I want to do, this is a company I want to work for, and hey, can you look at my resume? I'm preparing for my interview. I'm like, wow. And I had this internship. I'm like, wow, it's very fascinating. I wish I would have this kind of opportunities when I was in college. So it was really, I'm like, wow, I like this. And also I really like that it was towards the Latino community, especially, to become, so we can become role models for our community.
Exactly.
And it felt like en casa in there. The thing is that it was more towards undergrad at that point. So I feel a little bit of disconnection there. But shortly after, I received an email, and she was the person who got me into chef mainly. Her name is Dr. Andrea Rocha. We are tocayas. And she was the regional graduate representative for Region 7. And she sent out an email for all graduate students, and hey, come for a meeting. And she talked about the benefits of being in chef as a grad student and what chef did for the community. And I found it fascinating. And she would say, yeah, and there's the national conference. There's also the regional conference, and you have a leadership conference. I'm like, wow, this is great. And just to see how she would express and talk so confident, it was fascinating. I mean, for me, that was. I was like, wow, I want to be like her. That is great how she's a leader. I mean, she was great on presenting everything about chef. And so I was interested, and I asked her, can you elaborate more on chef? And she actually, she went through it, and then she said, we actually have a position open because I'm graduating soon, and I'm the regional graduate representative. So I need someone to take over my position when I graduate. And I'm like, okay, what is an RGR? What is that? So she explained to me her role and how she interacted with other students among the nation. And that even fascinated me more, because then it was just not that I was going to be exposed to the community in the University of South Florida, but also interact with other students across the nation. So she's like, if you want to check it out, come with me to the regional conference in Orlando. It's in 2 weeks, something like that. And I'm like, yeah, sure, let's do it. So in there, I had the opportunity to meet some of the graduate leaders, regional graduate leaders at the time. This is when Region 4 and Region 7 will have the same conference. So this is back in 2011, something like that. Yeah. It was called ETLC. So I met, very talented people, and also attending to the workshops. And I realized that this is this whole leadership and how to have these skills when you're actually giving a presentation, and what to put in your resume, what not to put, how to prepare your career goals in the next 5 years. And this is great. I need this, because I didn't have this kind of direction in my life. Yes, I was doing a PhD, but did not know exactly, where was this going. I did receive great advice, and that's why it's very important to have mentors from a very good friend called Margaret Dugarte. She was actually one of the PhD students that I talked to before starting grad school.
Okay.
But she was not chef related. But this is I just wanted to bring the importance of mentoring.
Correct.
So this is how I got into chef. Just going to a conference, the ETLC, and being also mentored by Andrea Rocha, and after she graduated, then that year, the end of 2011, I became regional graduate representative, and then I had the opportunity to meet the whole leadership at the national conference, and at that time, Peter Rios was the national graduate representative, and we were a really great team of all graduate students, and it was fascinating to talk with other PhD students, and I'm seeing that we were all going through the same struggles, that we had to get our papers done, that we should be writing, not here at the SHIP conference.
Yes.
So it just give you, it just really gave me like more enthusiasm and more passion to see that I'm not alone doing my PhD. We're all going through the same struggles, and it's fascinating that we can all interact, talk, and share advice, because we were all at different levels. So I think that when I started, I was on my second year, but then there were other students that they were about to graduate. Other students they were in their also in their mid-year. So it's like, this is the conference I attend to. This is my advisor works this way, and it was fascinating how we're all in the PhD track and seeing all the differences. Based on advisors, on classes, on publications, on conference attendees, but one goal in mind: graduating. Finish. You should get into the finish line, and I think that looking. And that really gave me encouragement. See, like, oh yeah, I applied to this grant, and it really pumps you up. It's like, yeah, this is great. Like, I'm on the right track, and it gives you that boost after being a chef conference, and then you come back and you're more inspired, motivating, and saying, let's do this. This is great, and also fascinating to talk to undergrad students and say, oh well, I did this is my PhD track, and seeing undergrads saying, wow, I want to do what you did, and you're like, wow.
Now you're the mentor.
Yeah, I'm the mentor. It's like, wow, it's fascinating. It's all a cycle, it's a circle,
Exactly.
and being part of that community, and seeing graduates helping undergrads, but also vice versa too, because you're just really learning. I think mentoring it's a feedback kind of loop, right? And then also having the experience with professionals, and then that's where I went to I run for national graduate representative, and with this position, I became part of the SHEP board of directors, and it was also fascinating to see the regional vice presidents all in one room, with the SHEP CEO, with the SHEP national president, with the SHEP vice president, with the national secretary, and see all this group committed, for one mission, for one vision, and see how these people were actually, we're volunteers. We're doing this because we want to. And I don't know, it was just it was great. It was a great experience, and learn from everyone, diverse background, but being there for one mission, one vision, and that was very fascinating.
Yeah, and I know you didn't stop there. I know you had more positions, and actually, due to time, I want to highlight what you're currently doing, because maybe you want to give a plug, but I know there's a national conference coming up, and you're very involved on Latina Track. Do you want to bring that up and kind of sell that, right?
Yeah, I was actually I expressed my interest in continuing with Chef last year to Mauro, and so he basically said, well, this is the opportunities that you have, and I told him that Latina Track sounds great. If you hear of if they need any help, let me know. Usually, from what I see, what I heard is the Latina Track usually is 2 organizers. So I told him, yeah, I'm definitely up for it. This is going to be great. Although, fun fact, I've never attended a Latina Track, but I've read about it in the Chef magazine. Always hear amazing things. Because I was so involved with the graduate leadership that, this was mainly my attendance for the conference for. So this summer, Mauro and Beatriz Garcia from the chef staff, they reached out to me and they asked me if I was still interested, and I said yes. And also, I had the opportunity. I'm co-sharing the Latina Track with Jimena Aristizabal, and it's very fascinating because when I was national grad representative, she was the chef president at her chapter, and we actually met through Facebook because she actually wanted to promote the graduate school in her chapter to the undergrad. So it's been great that actually we're back again working together. And right now we're going to have 6 workshops. Okay. We're going to have Alcoa, Cummins, ExxonMobil, which is actually the sponsor of the track, okay. Boeing, General Motors, and Facebook. So there's going to be 5. There are going to be 5 workshops, very presentation like workshops. But the 6th workshop, which is hosted by Facebook, is we're calling it the Power Celebration, and this is supposed to be more of a hands-on activity where there's going to be more engagement and more participation with the audience, with the actual presenters, and we're going to have a photo booth, and Telemundo is also going to be present there. Awesome. So it should be really fun. We have some games that Facebook is bringing. Facebook is coming with the LinkedIn organization. So we are very, very excited, and we have received a lot of support from the chef staff, and kudos to ExxonMobil who is our sponsor.
Correct. So can people still sign up? Get information.
Yeah, the Latina Track is open for every participant at the conference. We're going to have the track on Thursday and on Friday this week.
Oh, wow. It's coming up soon.
Yeah, it's happening soon. And no, people, you don't need to sign up or anything. So if you're on conference, already registered for the conference, you just have to go to room 314 at the conference at the
This is going to be in Baltimore?
Yeah.
Correct. Okay.
Convention Center.
Baltimore Convention Center.
Yeah.
So if you're going already to the SHIP conference, Latina Track, head over to room what?
What's that?
What room?
314.
314, okay. So I kind of want to wrap this interview with one last question.
Yes.
So being a Latina in a predominant white and male field, what advice do you have to young Latinas wanting to pursue STEM in graduate school?
Yeah, I mean, definitely, yes, it is a male-dominated field, but I think that what is important is have that si se puede attitude. I mean, you can do it. We can do it, like the
the power pose.
The power pose. Having that attitude of yes, I can do it, and having finding out the right mentors. And if I'm finding mentors, I don't mean asking someone, "Oh, do you want to be my mentor?" It's just having an organic relationship with someone that is more advanced or perhaps knows more in a certain field that you're interested in. So I think that don't be scared. Speak up. Try to learn more, to acquire more leadership skills. They're very important. That's very important for you to grow as not only as a professional, but also in your personal life. And really enjoy the ride. I mean, mainly don't be shy. Don't be shy. If you really work hard and take risks, then the benefits will come by itself. And don't feel overwhelmed that the majority of the people are men. No, I work in a very male-dominated group, and it's been great. I think I feel very fortunate of the group we work, and I always like to bring my perspective as a woman.
Exactly.
as an engineer to the table. So I always not make sure that I always like to bring my perspective. Yes, sometimes I'm out of my comfort zone, and maybe I'm quiet or I don't speak up enough. But I think that comes with time,
Correct.
and just have that you can do it attitude. That's the number one thing. And remember that
I
to
totally agree.
for good things to happen, you have to get out of your comfort zone.
Correct. And I totally agree because we need more diversity, including the males and females, because
Yeah.
they do bring a whole different perspective. Just natural. Um, there's characteristics that they bring that sometimes as males we overlook, and
Mhm.
again it goes back to diversity and getting a diverse group of different ways to approach and solve a problem. So
Exactly.
anything else, Andrea, before we wrap up this
No,
interview session? I know we mentioned a lot, but also I know we haven't covered a lot.
no, that's
Um,
fine. Yeah, because I think I expanded like much during my
no,
first
and it
question.
shows how fascinated you are in topics and why you did your
Yeah.
PhD in. But is there a place where they can maybe contact you, maybe through LinkedIn?
Yes, please. Feel free to contact me for my LinkedIn. I actually have received several emails from individuals from undergrads asking for for some mentoring, and I really enjoy that. I know that sometimes because of time constraints, I'm not the fastest
We're all
send
busy.
those email. But yes, this is my LinkedIn right here. Feel free to click on the blue button that says connect, and let's
Awesome.
start a great friendship from there. Yeah, and I would say grad school was the best decision I've made so far. That was I'm really happy that I took this route, and also working for the NBGO, going to an actual industry track. Also, I've been learning a lot because this is what I think I never answered your question, but the reason why I also went to the industry track is because the current group that I work with mainly they hold PhD. So I'm in a research and strategic group, research and innovation group. So we do a lot of research. It just we happen then not to be in a university, but we're a group of 10 people, and all these engineers are at various stages in their career. So they have provided me a lot of insight and a lot of help um, to actually to look at things as a different perspective, and they bring more things to the table. So it's been it's been fascinating ride, and I'm glad I chose this route. So, but I never discard the fact of becoming a professor one day,
One day.
because as I said, my dad was a professor, my mom was a teacher. So I think that I do have that passion for teaching as well, but another yet.
Well,
Yeah.
thank you, Andrea Sanchez, for your time,
Thank you
for
so
your
much, Juan.
dedication, all this energy. And again, I just also want to congratulate you for all your achievements, with everything you've done. And I'm sure you're not done. You still have many more goals, and a seguir adelante to go
Gracias.
forward. Well, thank you for listening to another episode of Tonight in STEM with Doctora Andrea Sanchez. With that said, please subscribe. I have a YouTube channel, there's a Facebook page, there's even Instagram. Please subscribe, share, please, so I can keep this going. Again, this purpose is to motivate other students to pursue STEM, and that there's a lot of role models out there you can model and look up to. But with that said, thank you for listening, and Tonight in STEM.